Welcome to problem 916 on page 288. This is the first Excel example from chapter 9 on hypothesis testing. In this particular case, we have our bottled water, as has been a theme throughout the course, and we are given the fact that they want to test whether the actual amount of water in the 1 gallon bottle is actually 1 gallon or whether it's different. So when you read that, if you were to write that, the mean is equal to 1 gallon as the null hypothesis. The mean is not equal to 1 gallon would be the alternate hypothesis. So that means it is a two-tailed test. What you may have noticed on the screen at the bottom of the workbook are the worksheets. And in this case, we have several of them. There's actually, I believe, 5 altogether. So you have to be careful as to which one you select. So this is a two-tailed test, and it wants us to use the Z values. Normally you use the T values, but in this particular case, they want us to use the Z values. And normally when you have a sample, you would use T. So that should be your mode of operation. So the null hypothesis is 1. The level of significance is, in this case, 1% or 0.01. The level of significance, as you learned in previous chapters, is the size of the tail. So because it's two-tailed, there'll be 0.5% on the left and 0.5% on the right. The population standard deviation, in this case, is given to us as 0.02. If we were to do this, I want to make a point here that if we were to do this in industry, we'd actually use T values, but this is a little bit old school where they want us to use the Z values, but that's fine. Most of them that we're going to focus on will be T values. The sample size is 50 bottles, so we have 50, and the sample mean turned out to be 0.995. So in the calculations that are all done for you because of the spreadsheet, what you need to be able to read is, it shows you the lower critical values in the upper, which are the old way of doing the hypothesis test before we started using more technology, because calculating p-values directly was difficult. It wasn't easily available, but with Excel and other forms of technology, you can see the statement here in cell C17, and the fact that the normal distribution, normal standard distribution is built into Excel, then you can see that calculating the p-value is not a big deal. If the p-value is less than the level of significance, we reject the null hypothesis. If the p-value is not less than, in other words, is equal to or greater than the p-value, we do not reject the null hypothesis. So even in the spreadsheet that you have, you can see that there's a conclusion with the if statement in cell C18, so you can read the conclusion. Because in this case, the p-value is 0.0771, which is larger than the level of significance at 0.01. So when you compare the two, in this case, the conclusion is do not reject. The p-value is the modern way of doing things. I would never present to a board of directors or my bosses the critical value approach, which is, by today's standards, old school. So we're going to use the p-value and we're going to use our spreadsheet. So be careful that it's two-tailed. In this case, it should actually have been a t-test because we have a sample size. The z-scores are when you have a population, but the book uses it this way, so we'll we'll do it this way just to give you an introduction to this particular spreadsheet.